Hello, everyone. Welcome. Thanks for coming today. We have a very big group, so it's perfect. Welcome to Flywire, and today, well, many of you probably...
Sorry.
Porque se me oye. No quiero oírme. Ella no se quiere ver y yo no me quiero oír. Okay. So welcome to the Hack Nights. Probably most of you already know what Hack Nights are, but just as a refresher for new people and just a reminder, we do this every last Thursday of every month. We have different methodologies of Hack Nights. Sometimes we do more hands-on workshops. We do talks. Sometimes it's people from Flywire, sometimes, like today, it's people from outside. So if you want to give a talk and you want to come here, feel free to do so. Just talk with us, anyone with a blue shirt. And yeah, you can come here and do a talk, a workshop, or whatever you have in mind. You are more than welcome. So today, we have a very, very nice invite here. She's Carla. She is working in Okta, and she's gonna present a talk. So I will leave you to her. Thank you, Carla. Welcome.
You need to wait. All right. Not that I'm gonna use this, but it's nice to have it. Where? Can you see me there in the camera? Oh, I have to stay here then. No, I can't move and be like, eh. Here. There? Okay, cool. Well, hello everyone. Thank you so much for being here. I know you probably are coming from work, and this is awesome that you're all here. Today I'm here to talk to you about this new technology that is called Passkeys. So brace yourself, because Passkeys are coming. Now let's see if this is actually working. Yes. So let me start by introducing myself. Sandra already said some nice words. Thank you very much. But my name is Carla. I'm a senior developer advocate at Auth0 by Okta, which is an identity and access management platform. Basically, we deal with all things authentication and authorization for your applications. I've been working as a software engineer for about 10 years already. And you can find me as Carla Stabile almost everywhere. If you don't find me, it's because I don't want to be found. And yeah, that's pretty much it about myself. So, what are we going to be talking about today? The first thing is I want us to talk about the password problem. Then we're going to discuss some of the alternatives that we've proposed for the password problem, and that is passwordless. Then we're going to dive into Passkeys a little bit. And finally, and if it works, I'm going to show you a demo that I prepared for you today. So, the password problem. I think we can more or less agree that passwords just suck. I don't know. I don't know about you. I hate passwords. If you like passwords, can you raise your hand? You like passwords. What's wrong with you? Who hurt you? Okay, well, to me they suck. They've been around for a long time, and as our technology keeps growing, they just become more and more vulnerable. Nowadays, you can use a password manager, and I'm sure most of you probably use like the Google Password Manager or iCloud, whatever. But you can still be a victim of a social engineering attack or even a phishing attack. And then, from the implementation point of view, if you've had to implement an authentication system yourself, it's just annoying to deal with. You have to deal with things like password encryption, or am I implementing the password reset flow properly? Is my database secure enough? Is it going to be attacked by someone? All these sorts of things, and it's just stressful, annoying. I personally hated it. I don't like it. And so because of these reasons, and probably many other reasons that I'm not here to talk about, we've come to propose a solution which is passwordless. And passwordless is basically any form of authentication that doesn't require a password when you log in. An example of this can be when you log in into a system. Hi. When you log in into a system and the system sends you a link through your email, or you receive a code via SMS on your phone, and then you don't have to enter any other thing other than probably your username or email. But the thing about passwordless is that it offers a solution to the password problem, but then unless you have different authentication factors or use multi-factor authentication. Are you familiar with multi-factor authentication? See a lot of nodding? Yes, awesome. But the thing is, unless you implement multi-factor authentication, you're not entirely secure. It's better than passwords, 100%, but it's not the best solution yet. And I've talked about factors, and I want to take a little moment to explain what I mean by factors. So basically, we have 3 authentication factors. We have knowledge, possession, and inherence. So knowledge would be something that you know, that would be the answer to a security question or a password. Possession would be something that you have. That could be, for example, in the passwordless example I was talking about, that link that you get to your email or the code that you get to your device. And then we have inherence, and that is something that you are, something that is inherent to you. For example, any biometric like your fingerprint or your face and so on. And the thing is, the more authentication factors you add in your system, the more secure it's going to be. That's the whole point of multi-factor authentication. And adding them up will increase what is known as the level of assurance. The level of assurance refers to how confident you are that this user is who they say they are. For example, if we look at this image, we'll see that we go from low assurance on the left to high assurance on the right. Thank you for removing my image because I did not want to see myself. And we increase the level of assurance as we go to the right side. So in the case of the answer to a security question or a password, those two things are very easy to guess by an attacker. So that gives you low assurance that that user is who they say they are. And then as we move forward to the right side, we move to FIDO2, WebAuthn, and biometrics. And those things are harder to guess for attacker because FIDO2 and WebAuthn use cryptographic algorithms, and it's very hard to like reuse your biometrics by someone else. Like they need like your finger and stuff, and not fun. All right, so luckily for us, passkeys are on the right side of this chart, and we're gonna talk about it and see why. But before I do that, I'm wondering, have you heard about passkeys before? I would like to see some hands because I don't know. Okay, are you using passkeys? Less hands, but still some hands, so that's awesome. Great. So for those of you who don't know, passkey or a passkey is a unique cryptographic key pair that you can use to log into an online service without using a password. And it's based on asymmetric public key cryptography, which sounds very fancy. But the chances are you've probably already used this in the past. If you've used, for example, Git and have to set up your SSH keys, this could be a form of public key cryptography where there is a private key and a public key. The private key is obviously private for everyone except for you. It's only available for you. And the public key is available for everyone. And the beauty of it all is that anything that you encrypt with your private key can be decrypted with your public key and vice versa. And just by using that, we're adding already another level of security on top. So we're increasing little by little, as you can see. We have 2 types of passkeys. We have sync passkeys and device-bound passkeys. So an example for sync passkeys, you can think of, I didn't want to say that example, but I put the image, so I'm going to stick to it. When you use iCloud and you synchronize your password or your passkey there, that would be a sync passkey. So it's basically a way to have your passkey available in multiple devices. And for that, you have to sync it to some sort of cloud-based service. The Google Password Manager would be also an example of this. And then you have device-bound passkeys that, as the name states, they're only available in the device that they were originally created from. And I think I brought my YubiKey, because my YubiKey would be an example of that. It's the same one that you see there. But also your Mac, if you use a Mac, that could also can create device-bound passkeys as well. The difference, like the big difference between these two types is where does the private key lives. We said in the past, like a few minutes ago, that a passkey is a public key, a key pair, sorry. And so in the sync passkeys case, the private key lives on the cloud. You have to synchronize the private key to the cloud in order for it to be available in multiple devices. While in the device-bound passkey case, the private key will never leave this device or the device where it was originally created. So you can state that this could be more secure because it's not synced anywhere. It's literally in my pocket. Like, you need to kill me to get this passkey. I'm just kidding. Don't do it. All right. What do we have next? Next, we have what are the components or the entities that are involved in the process of passkeys? We have three. That is the authenticator, the client, and the relying party. I forgot to mention, if you see some QR codes, you feel free to scan those or go to the link. They go to the same place because there's a little bit more information if you're interested. If not, that's also fine. So the authenticator would be the device that creates that key pair we were talking about. Could be my Mac, could be my YubiKey, for example. Then we have the client, which is usually a browser, but not necessarily. And then we have the relying party. The relying party would be the server or the service that you're trying to authenticate to. For example, for those of you that have used Passkeys, you probably used it with Apple or with Google, and that is what the relying party would be. There's also a little bit more information here, but I don't want to get into too much detail in there. Just want you to know that the client and the authenticator communicate with each other using the CTAP2 protocol, and the client and the relying party communicate with each other using WebAuthn, and all this together comprises a standard called FIDO2. I'm happy if you just remember FIDO2, honestly. All right. I think I spoke pretty quick, but I'm going to the demo, and I don't know how I told this, but part of my personal brand is that my demos don't work when I do it here. So we're gonna see if that works. I basically wanna show you how the registration flow and login flow works when you use the passkey. So I built a demo, which is not running, don't worry about it, I have to run it. How do I go there? Click. Okay, now it's running. I have to look at it there because I don't have it in my screen. All right, this is a very short demo. Like, it's basically just this. So I'm gonna go and sign up so you can see how the sign up flow works. Of course, I'm using Auth0 because I work in Auth0 and I have to use it, and it's also amazing. But yeah, I'm gonna use that. So as you can see here, I only have one field that I have to fill, which is my email, no password. So I'm gonna create a passkey with, I don't remember how many users I've created. So Gmail, no, test.com. And then I'm gonna click continue. Here I get like a little prompt saying what's going on, what is a passkey. So I'm gonna create a new passkey, and then my browser is now asking me, okay, well, where do you want to create this passkey? For fancies, we're gonna create it using my phone, so you can see the multi-device functionality going. So I'm gonna go, so you see the options are iCloud or your Chrome profile, that's basically the Google Password Manager, but I'm gonna do it with my phone. So the thing is, I have to scan this QR code. Please don't scan it. The beauty of this this QR code is it works by Bluetooth and proximity. So that's why I ask you don't scan it, because we're in the same room and probably can get it. But I can follow the steps now on my device, and here I have to use Face ID to log in. So I'm gonna click continue on my phone using Face ID. And then I have some authorization that I need to accept because I need access to my profile, but I'm basically logged in now. If I didn't break it, I didn't break it. Great. Cool. So I think I'm gonna risk it because I changed it this morning, but I'm gonna click here. I have a sync passkey here, and it says sync passkey because I created it with my phone. Therefore, it had to be, the private key had to be synced to the cloud. So now we're gonna log in, and the process is quite similar. God, this is hard. Log in. And then I'm gonna click continue with a passkey. I can click here, or I can click the email field. And something I haven't mentioned about passkeys is that if we get like more technical, a passkey is actually a discoverable credential. And what discoverable means is that the browser has the ability to know which passkey has been created for this particular service. So I've created a bunch, as you can see, and it's telling me, okay, on this device you have all these passkeys, and then on other device I would have to use my phone for that. So I'm gonna do that again because I created it on my phone. There we go. Once again, it's asking me for. It's going to ask me for my Face ID. You can't see it. Oh wait. I have a bunch of passkeys here created as well. Let me select the one. It was 45, right? Carla 45. Click continue. Use my face, and then I should have my passkey created. Now, because this is at 0, it's asking me, oh, do you also want to create this passkey on this device? I personally don't want to, so I'm just going to continue without a new passkey because I just want to keep the one that I already have. And if I go to my passkeys, then I just still have my good old passkey. So that's basically how it looks like when you use a pass, or how the registering and login flow looks like when you use a passkey. But what the hell is going on under the hood, right? Like the browser is doing stuff, my phone is doing stuff, and I have another little demo. But this is a website, so honestly, if this fails, it's not me. Okay, I need to go back to my slides. Let me figure that out. Go like this. They are lost forever. I'm back. I don't see my slides. Okay, maybe they're here. No, this is my, we lost them forever. Well, that's fine. I'll just go directly to the website I want to show you. Hello. You would think I know how to use a Mac, right? Let's close this. Come on. There we go. Have it right here. Hello. All right. Is that big enough, or should I zoom in a little bit? Let's zoom in nonetheless. Bloop. Okay, that's better. All right. So what I'm gonna do here is I'm gonna basically do the same thing I already did on my little demo app, but you gotta pay close attention to the 3 components we were talking about just now: the authenticator, the browser, and the relying party, because there's gonna be some interaction going on. And this is basically gonna show you what data is being sent to where, and after the fact, I'm gonna explain you out loud just to make sure it's clear. So once again, we need to provide a username or an email, no password, and we're gonna click register and pay attention because it's fast, okay? All right. It's not as fast as I thought, but it's fast. Okay, similarly, I have 30 seconds. what is happening here is once I click on create my new passkey, the browser is sending that information to the relying party. And the relying party is saying, okay, I don't have this user registered. Let me send them a challenge so they can cryptographically sign this. And they send that information to the browser, and the browser is like, okay, let me send that to the authenticator, which in this case is my Mac. I have 6 seconds. So I'm gonna create it on this Chrome profile. It took me too long. But it's okay, we have time. We got it. And then we're returning some stuff. So what happened there is, once I use my fingerprint to assert that I want to create the passkey, and this is a very important step because you need to have that user interaction when you're doing this kind of authentication. The authenticator is going to sign that challenge that was sent by the relying party, and then it's going to create the private key and the public key, and it's going to send the private key ID back to the relying party and the public key. Note, it's going to send the private key ID to the relying party, not the private key itself, in the case of device-bound passkeys. So the information that is being sent there is actually not attractive to attackers. Everything is public. If anyone gets there's no sensitive information there, which is already making it less attractive for any attacker. So we have a passkey created, and now I can use it. In fact, you can see it here. As I mentioned, a passkey is a key pair, and this is my public key, sorry. You can see some information about it. So we're gonna use it. I'll click next, and I'm gonna authenticate with my credential. This is the information I'm gonna send to do so. I'm gonna say, look, okay, wait, let me scroll down so you see the interaction again. Once again, the browser is gonna send some stuff to the relying party, and there's a slight difference, but it's an interesting one. All right, so in this case, the browser sent the information to the relying party, and the relying party is saying, okay, this user is already registered, so let me send a new challenge, so it's signed, but let me also send the key, the public key, which was used to create this particular passkey. So that is sent back to the authenticator, and the authenticator needs to use the same key that it was used originally to create the passkey to sign this challenge. So I'm gonna go ahead, assert, and sign the challenge and send that information back to the relying party. And after that, the login was successful. And that's pretty much how the flow of passkeys work. I think I can get back to my slides now. Yes, we can. I don't need my notes anymore, so we're good. Cool. So I show you my Passkeys paradise. I don't know why I call it Passkeys paradise. It's not really a paradise at all, but you know, it was like PP. And this was the little bit of the deep dive we just did. And I have some resources in case you want to see them. The website I just used is the one on the left. It's called webauthent.me. If you want to learn more about passkeys in depth, like that whole interaction that I show you between the authenticator, the client, you can really see more information about it because I just gave you like a glimpse of it. And then one thing that I wanted to share with you is the Valencia Tech Fest is also coming on June 8th. So you should go, you should propose talks. And there are some of the organizers are actually in this room, so you can talk to them as well. You want to raise your hands, or you're too shy? There's one there, one here. There's a lot of people. Okay, you can talk to them if you want to propose a talk, or you can also just go to valenciatechfest.org. And with that, thank you very much for your attention, and I'm ready. I'm bracing myself here for questions. Yes.
It's similar on hash.
A hash. So a key pair. It's a cryptographic. Honestly, I'm gonna rely on the security people in the room.
Do you want me to answer?
Yes.
Okay. No, it's pretty different because a hash is a checksum, that is a mathematics summary of the information, and it's not a secret or it's nothing to do with secrets. Then anyone can calculate a hash. But in this case, it's a key pair, public and private. Then everybody could have the public one, but no one, only you should have the private one.
He also works at Okta, by the way. I'm taking advantage of that. More questions. Hopefully, once I can answer. Yeah.
So users usually lose passwords, and they probably lose USBs too, or phones.
Mm-hmm.
So how do you recover your account if you lose your passkey?
This is a conversation I've been having a lot lately because yes, that is a concern people have. And remember I was talking about multi-factor authentication, and with Passkeys, it is also recommended because of the same reason that you have multiple factors set. Not necessarily a password, but you can have, for example, that you get an, an link sent to your email, or using WebAuthn, which is similar to Passkeys. I'm not going to get into that. But you definitely need to have other factors in place in case you lose your passkey, and that way you can fall back to one of the other factors.
Is it possible to have multiple passkeys to authenticate? For example, it's pretty common that a while ago we used to use RSA as an algorithm for cryptographic pair keys, but now it's outdated. Now everybody's using new algorithm. So when the current one is outdated, that hopefully will not happen soon, most of the passkeys will get outdated. So probably we need to create a new passkey. Is it possible to change or add new passkeys to authenticate, or is just only one supported?
No,
For
you
a
can.
single account
You can have as many passkeys as you want. Yeah.
for the same account, not for different accounts.
I think it depends, because like having a passkey and a user account is not the same, but it really depends on how you define it on your application. Like in my case, in my little Passkeys paradise, I could have 5-6 passkeys defined. You have to have one here, like one that is synced. Like I don't think you can have like 2 for the same authenticator, same service, and same account. Shoot. Any other questions? Yeah.
How does it work with the multiple devices and also a provider? Actually, are you like a, I don't know the exact term, but like a middleman? I understand the old zero. It's like a, not like a provider, because you mentioned the relying whatever.
Auth0 would be the relying party in this case. In my demo, Auth0 would be the
So
relying
it's not
party.
Google anymore, nor iCloud, it's O0.
You have to sync it. Depends on what you use
And
for.
you can probably implement your own as well.
Yes, you can implement your own relying party yourself, and there are many libraries for that. I use Ruby. I know there are people with feelings about Ruby, and there is one called WebAuthn Ruby, I think. And that specific library, for example, is to build your own relying party and your own authorization server.
But then you probably need to like store some information on your site
Yes.
and everything.
Yes.
Exactly.
So that's what Google, Apple, and Okta do for you that you don't have
What
to do.
you mentioned at the beginning, that with Passkeys you are basically out of these troubles.
Yes.
It's another thing there. And also another question, I found like every time there's like multi-factor like login or like security, I found it like more complicated than with the regular passport. I know there's an additional level of
Yeah.
security and everything, but then like from the user perspective, it's more troublesome. You need to, where's my phone? And so you get there, like open the
I've done
phone
that.
and
Yes.
find the app and everything. So do you see sometime in the future we will get rid of like these steps, these extra steps that are there?
Yeah. So the question, well, there were a couple of questions, but the question is about, I think, the adoption issue with users and educating users on using this. And as user, I mean ourselves as well, right? Because as you say, it's annoying. Sometimes I have to I gotta go to my authenticator and put the code and whatnot, and that's annoying. I don't know how it's gonna be in the future. I do think passkeys, especially when you use them on your phone, can be more easy for users, because when you're using your Mac, you get this prompt to put your fingerprint, and there's some stuff going on, and it's not as natural. I think people are more used to like just putting their faces or putting their fingerprint on their phones. It is the same process in the end, but it feels more natural to people to use it on their devices. That was one part of the question, and the other part of the question I forgot. The initial part. What was it?
No, it was about the
Ah,
complexity.
Using multiple factors.
Yeah, in general, like the complexity that it may have. But probably what you like the answer should be like basically if you are using the same device for both the multi-factor authentication and the application itself.
It shouldn't be as, yeah. I mean, if you're, for example, in this case, I was using my phone. If I created my passkey on my phone and then I have another factor to send me a code through an authenticator app, I would probably have that on this phone. And yes, it could be a little bit more annoying. And I remember what I wanted to say earlier, that something I didn't mention in this talk because I thought that I wasn't going to have time, but I'm going to say it anyways, is the challenges of passkeys. And user adoption is definitely one of them because of this reason. Because users, everyone is super used to just using a password. You know, that's what we're used to. And that's one thing. Another thing is the reliance on vendors like Google, Apple, Okta. You know, someone has to store your passkey if you want to use sync passkey, or if you want to use this one like device-bound passkeys, that's fine. But for sync passkeys, you have to rely on an external cloud service to do it for you, and some people don't like that. So that is another challenge of using passkeys and getting more adoption for users. That's definitely another challenge. Yeah.
Another question. So the relying party, you cannot choose it. The website that you are using or the tool you are using chooses the relying party. So at the end, they force you to use a provider. Like you cannot create your own relying party and integrate. Like when you log into a page using a passkey, say, okay, but my relying party is my own.
You can if you create like device-bound passkeys, but if you're using sync passkeys, unless you implement it yourself, which I'm not sure if it's possible, I'm gonna be honest with you, you need to rely on like Microsoft, Google, Apple, Okta.
I'm wondering if there are any recovery options. For example, I forgot my PIN code, and what's going on in this situation?
So there's the option of having the fallback of other authentication factors, like sending the email, getting a code on your phone. And then I had a conversation with someone that really shocked me because they were implementing passkeys. This was like not related to what I'm doing right now, but just in general having a conversation. And the way it was working for that particular company is they had to call customer support and say, okay, I can't access my passkey anymore. And they would ask them questions like, okay, tell me your name, tell me all this information, which is like another factor, but it's very manual and it kind of loses the purpose of using passkeys. And then they manually can revoke your passkey and use it. The way I want to do it in my demo application that I'm building is you can revoke a passkey and then you can re-enroll and like enroll a new one. This definitely depends on the type of business that you have. For a demo, like a random demo app that I'm doing, I just have a button that says revoke and then I create a new one. It's like whatever. But a passkey could be very, very valuable for users in the end. And making that decision of, okay, I'm gonna delete one and get a new one could be a big decision. But in the end, yes, so far the recovery mechanisms is falling back to other authentication factors, hopefully ones that are more on like the right side of the spectrum and not like security questions, like the one with customer support. But yeah, that's where we are right now. Something that I might have not mentioned is that passkeys are still very new. I think the term passkeys became known in like 2022 or 2021 because Apple mentioned it. And it's still evolving. So this whole recovery flow, it's going to keep changing. In fact, I think last time in January, we had, I think I created a blog on Passkeys, and then I had to change it in April last year. It was January last year, and then I had to change it in April because the definition changed. You know, it's like, oh no, Passkeys are not that anymore. Now they're this, and you're like, okay, you know, you have to keep up because it's still very new. I rambled a little bit, but yeah, fallback authentication factors is a summary. Yes.
Talking about the issues around users, like, what's the drop-off? Let's say I've got an app and I'm having people sign up with a password and an email, like, versus this, like, how many people would I lose? Like, do you have any statistics on how difficult users find it relative to more standard or known options?
I don't have those statistics actually, but I think that would be something very interesting to know. But I don't have the statistics, I don't.
So one of the options that you had for storing your passkey was iCloud, although you didn't choose that one. Will that, in theory, work as some sort of vault or something, some sort?
Yeah.
And then skip the 2FA?
In fact, you can use like 1Password or any other like password manager apart from, that's a whole, I don't use 1Password, but that's something you could use as well. No, it's not limited to iCloud. I think apart from 1Password, maybe I think Bitwarden is also a password manager as well, and you can use Passkeys as well. Yeah. There's like, you know, a lot of people are coming with their own like Passkeys managers, but it's still growing. So yes.
How do you deal with, like, for example, a user in their PC, Mac, wherever, they have created their passkey, but it's on Microsoft Edge, so it will be available on Microsoft Edge, and then I come to my iPhone, try to log in Carla's Passkey Paradise, and it doesn't have my passkey because I'm not using Edge on the phone. How do you deal with all of that?
I don't know if you can create passkeys on Microsoft Edge, if I'm honest with
I'm
you.
just saying because it comes like by default with Windows, so I can imagine someone who's not like very into technology could just say like, yes, just whatever, I want to log into this.
I'm not sure, especially because I think Windows is a particular case. I think what they do now is they make you use Windows Hello to use passkeys and whatnot. But outside, can you give me an example that is not for Windows? Because for Windows, I would have no idea.
I'm using Chrome on my Mac, I guess, and then my Android phone.
And you don't have Chrome?
Yes, I have Chrome. Then I'm using Safari on my Mac and Chrome on my Android.
Okay, got it. I mean, in that case, once again, you can fall back to another authentication method. But if you wanted to use your passkey, then if you're using Safari, it's probably synced to iCloud. And if you have your Android phone, you can use the multi-device feature and scan the QR code. And that way you can get access to that passkey. Even did you notice when I went to log in and I scanned it with my phone and it asked me, do you want to create a new passkey? That's what would happen in that case. Because in that case, I created it on my phone first, and then my Mac was like, but do you want to have a passkey here as well? And I said, no, I just want one. In that case, you can like have another passkey for that account, which would be an example for your, look at me, linking questions. More questions.
That's it.
Nice.